All right, this is an interesting problem. This is an application. In other words, a real life place in which we deal with GCF. Remember what this section has been all about? It's been all about GCF and GCD. So in a local recreational soccer league, there are 252 men and 30 women signed up to play soccer. So the organizers need to make sure that everyone gets on a team. The teams are the same size. Each team has the same number of males and each team has the same number of females. That makes sense. So they want to make a bunch of teams that all have the same number of men and women. Question is, what is the largest possible number of teams and how many people will be on each team? This is kind of an interesting sort of question. How do we actually answer? Excuse me. How do we actually answer this question? Well, let's just try guessing at first. So a lot of times guessing is a good strategy just to get you thinking. So what if we just make two teams? I mean, that'd be kind of crazy, I know. Well, let's just start. If we only made two teams, then we would need to take the men and divide them in half, right? Because they got to have, each team has to have the same number of men and women. If you divide that on your calculator, you get 126. So you got to have 126 men, and if you divide the number of women by 2, you get 15 women and 15 women. That's a lot of women and men on each team. I mean, that's crazy, isn't it? Right? 126 men and 15 women on each team. That's crazy. We got to have more than 2 teams, clearly. All right, but it just gets us thinking. Let's go to 3 teams. What if they decide, hey, we're gonna make 3 teams in the league? Well, then we'd have to divide the number of men into 3 even teams and the women into 3. Use your calculator. I'm going to use mine. I'm getting 84 men and there'd be 10 women. So that'd be 84 men and 10 women on each team, right? Well, that still would be a lot, right? You don't want 84 men and 10 women on each team. That's still a bit too much. Let's keep going. It just gets us thinking. How about if we broke the league into 4 teams? Bring it over here. What if we made 4 teams? Well, divide by 4 the men, 252 men divided by 4, 63, and divide by 4 here, 7.5. Uh-oh, look at that. It'd be 63 men and 7.5 women. You can't put half a woman on a team. So that's not going to work. We cannot break the league evenly, anyway, into 4 teams because there wouldn't be the same number of women on each team. And they want there to be, right? Each team has the same number of males and females. So we can't do 4 teams. Okay, that's not going to work. Let's go to 5 teams. What if we try 5 teams? So if we divide by 5 and divide by 5, 252 divided by 5, actually that's not going to go, is it? 50.4, that'd be 50.4 men, and divided by 5, this is 6 women. We can't do that either because you can't put 50.4 men. There's not a way to evenly divide them in. It's not going to work. All right, let's do one more and then we'll really do the problem. What if we divide by 6? What if we go for 6 teams? We make this into 6 teams, divide by 6 the men, the 252 men into 6 teams. You get 42 men on each team. And divide by 6 here, this is 5, isn't it? 5 women on each team. So that's on each team. So that's possible. We could make 6 teams, and it'd be big. There'd be 42 men and 5 women. That's still pretty gigantic. Anyway, we need to keep going. So we've done 2, 3, 4, 5, 6. So the question they're asking is what is the largest possible, right? The largest possible number of teams. Could they make 7 teams, 8 teams, 9 teams, 10 teams, 11 teams, 12 teams? How many teams can they make where they are able to have the same number of males and the same number of females on each team? Well, do you see that this is a GCD question? They're basically asking us for the GCD or the GCF, whatever you want to call it. They're asking us for the greatest number that divides evenly, right? Because that's what we're doing, right? We keep trying to divide the man number, 252 men, and the women number, 30 women. We keep trying to divide those two numbers by the same number. We tried dividing them both by 2, 3, 4, 5, now 6. And we want to know what's the biggest number that will go into both of those. That's the number of teams, isn't it? That's the largest, greatest possible number of teams, greatest common divisor. We want to know the biggest number that divides both those numbers. This is a real life GCD, GCF problem. So we know how to do that. We're pros at that. We have all kinds of tools. We have multiple methods, 2 methods, for finding the GCD and the GCF. Let's do it. So they're really asking us, what's the GCD or GCF, whatever, of 252 and 30, right? That's really what they're asking. We know how to do it. Let's do I'm going to do the prime method, but you could do the long divide, rotate thing if you want it. I'm going to take the 252. That's 2 times something. Divide by 2 on my calculator, 126. That 2 is done. Break down that 126 divided by 2. 63. Break down the 63. 7 times 9. The 7's done. 9. 3 times 3. So I broke down that 252 as far as it would go. Now let me break down the 30. That's easier. 5 times 6, and 6 is 2 times 3. So notice I cross off all the numbers that broke apart, right? See why I'm crossing off the 126, the 60? You see why I'm crossing this off and this off and this off and this off? It's because those numbers broke down further, didn't they? They're not prime. They're not the fundamental building blocks. They're not the prime building blocks. They broke down further. They broke apart. I just want the prime numbers that can't break down anymore. The prime numbers that can't break down any further. I just want those numbers that cannot break apart any further. I want the prime building blocks. Okay. So let's do it. So now you know what to do. We just line them up, huh? So here, back up here. Let's do the 252 up here. And what is 252? Looks like it's 2 2s, 2 squared, 2 3s, 3 squared, and a 7. I'll move the 7 over so I have room for everything. And then down for the 30. Now the 30 is a 2, a 3, and a 5. A 2, a 3, and a 5. All right. So let's do it. Let's line these guys up. With lines, I mean, we did line them up. Now let's put the lines in. And let's find the GCF or GCD, whatever you want to call it. All right. So what's the GCD here? Well, it's going to be what they have in common. Remember? It's the greatest common divisor or factor. So how many 2's do they have in common? Just 1 2. How many 3's do they have in common? Just 1 3. No 5's, no 7's. So what's the GCD? 2 times 3, right? You multiply those together. They both have a 2 and a 3 in common, 6. There it is. 6 is the GCD. It's what they have in common. In fact, we already found that out, didn't we? We already kind of by guessing, we found out that 6 was the biggest number that we found anyway. It turns out it is the biggest number overall that divides evenly into 252 and into 30. That's the greatest amount they have in common. It's the greatest common divisor. So 6 is the, let me write a 6 here. 6 is the largest possible number of teams they can make. And if they do make 6 teams, the question they're asking us then, if they make 6 teams, How many people will be on each team? Well, if you take the 252 men and you divide them evenly into 6 teams, remember you get 42. We actually have it right there. 42 men. And if you take the, 30 women, and you divide them evenly among 6 teams, you get 5 women on each team. We have it right there. And then, so if you add that up, you get 47 total people on each team if you have 6 teams. So that would be 47 total people on each team if you have 6 teams. So there it is, a real life application of GCD or GCF. Questions I can answer on that one?